Hi everyone. Today I'm going to share you the volume, how to find the volume of solid revolution by using integration. So let's look at the question 1. Find the volume of the solid generated by rotating the region R bounded by the line x equals to 3, y equals to 2, x equals to 0, and y equals to 0 through 360 degrees about the x-axis. This is the question A. And then that region is going to rotate about the y-axis for the question B. So let's look at the question A. So first of all, we need to just sketch the graph of this line first. Then we determine the region of R. Then there only we will find the volume. So for x equals to 3, how are we going to sketch the x equals to 3 is a vertical line, which is passes through the 3. So that's a vertical line. And I'll label it as a x equals to 3. Next, we have a y equals to 2. Y equals to 2 is a horizontal line which passes through the 2 at the y-axis. So label this as a y equals to 2. And you're going to find the region which is bounded by these 4 lines, which is x equals to 0 and y equals to 0. So I have an area which is bounded by x equals to 3, y equals to 2, x equals to 0, and y equals to 0, and the region will be here. This is the shaded region that we want to find. Then after that, this region, this piece of region is going to be rotated about the x-axis, and this is the x-axis. If this region, this piece of the shaded region, rotate about the x-axis, it will form a volume, a solid, which is in this shape. And it is a cylinder. Cylinder where the height of the cylinder is 3 units from 0 to 3, and the radius of the cylinder is 2 units. Now we're not going to use the formula to find the volume of the cylinder, but we're going to integrate. We use the technique of integration to integrate this function, and we automatically will get a volume. Alright, so to get a volume, our formula is when this region is rotated about the x-axis, the formula will be pi, and you're going to integrate from the limit which is located at the x-axis from a to b. For example, here it will be 0 to 3, and the formula is you are going to integrate the function y squared, alright, with respect to x. So meaning that now we have the function y equals to 2. So when you have taken the square of the y, you will get 4. So the function here now will be 4. So for this question, for this particular question, the a will be 0 and the b will be 3. Integrate from 0 to 3. And y squared will be 4 because this is the function y equals 2 is a constant function. Square of it, you will get 4. And you integrate with respect to x. So just integrate as usual. The pi will be outside, and integrate the 4, you have a 4x. Put in the lower limit as 0 and upper limit as 3. Then substitute the limit 3 inside, you get 12. Minus substitute the 0 inside, you will have 0. Finally, we have a 12 pi. And since this is a volume, we have a unit cube. So this is the answer for the A, part A. And now we look at the part B. So if, let's say, now the same region, exactly the same region, is rotated about the y-axis, so the different cylinder will be formed. Let's see. Yeah, this is exactly the same region, which is same as the part A, which is the area is bounded by the x equals to 3, y equals to 2, x equals to 0, and y equals to 0. So now this piece of region is going to be rotated about the y-axis. Alright, for 360 degrees. So we will form another cylinder, which is a shorter cylinder and and a fatter cylinder. So we try to sketch the cylinder that we can form. All right, so we take the length, the same length here, same length of this radius, and then we draw the shape. This is the cylinder. Alright, so we have this cylinder, and this cylinder compared to the cylinder just now, it looks more shorter and fatter. So now the radius is 3 units for this cylinder. The radius is 3 units from 0 to 3, and the height of the cylinder will be 2 units. So again, we're not going to use the cylinder formula, the formula to get the volume. We're going to integrate it because now this piece of region is rotated about the y-axis. We're going to integrate, and the same formula as rotate about the x-axis. We start with the pi first, and the limit, let's say is a c to d, the lower limit. For this case is 0 to 2. All right, the c is 0 and the d is 2, and we're going to integrate the function of x, all right, square with respect to y. And how do we get the x square? Because when it is rotated about the y-axis, we are going to refer to the function of x, which is x equals to 3, because this curve bounds the region. All right, so now we just put in the limit. For this case is 0, c is 0, and the d is 2. X will be 3, so x squared will be 9, and we're going to integrate with respect to y. Because it's rotated about the y-axis, you need to integrate with respect to y, and the limits also you need to get it from the y-axis. So integrate 9, you get the 9y. Integrate from 0 to 2, substitute the limit, then you have your 18 pi unit cube. So obviously, when you have a same piece of region rotate about the x-axis, it will be different by the answer, by the volume generated when this piece of region is rotated about the y-axis. It will be different. All right. So this for the answer A is 12 pi and the B will be 18 pi. For the question, example 2, find the volume generated when the shaded region is rotated about the through 360 degree about the x-axis. So we have this region already labeled as R, and now we're going to take this region, rotate about the x-axis. So after it rotates, the path that this region take will roughly will form this shape, this solid. This is like a wizard hat. So this is our rotation x-axis, and we want to get this volume of this solid. To get the volume of this solid, simple. We just need to stick to the formula. Start from pi, and because it is rotate about the x-axis, so we need to integrate with respect to x. And the limit, lower limit, we need to take from the x-axis also. That will be from 0 to 2, because the area, this region, is bounded by the x equals to 0 and x equals to 2. And we need to put in the function of y squared. So put in the function of y squared because of the y equals to x multiplied by x plus 1, meaning that the y squared will become x multiplied by x plus 1 squared. X multiplied by x plus 1, and this is going to be squared. So we need to integrate from 0 to 2. Firstly, just expand first. Expand this. You will have x squared plus 2x plus 1. Expand further. You have x power of 4 plus 2x cubed plus x squared. So now you are ready to integrate. Just integrate x power of 4, you get x power of 5 over 5 plus 2x power of 4 over 4 plus x cubed over 3. And put in your lower limit and upper limit. So now you just get ready to substitute the lower limit, upper limit minus substitution of the lower limit. Substitute 2 inside, you get 32 over 5 plus 16 multiplied by 2 will be 32 over 4 plus 8 over 3. And the 0 you put in, you will get 0 for the first term, second term, third term, or you get 0. So you get 0, basically you get 0 in this bracket. And now you, with the access of calculator, you can calculate this. Then you have 17, 1 over 15 pi unit cube. This is another example. Region R is rotated about the y-axis through 360 degrees. Find the volume of the solid of revolution. So we're going to integrate with respect to y because the volume now formed by this. If this region of R rotates about the y-axis for 360 degrees, so we can roughly sketch the solid that we can form. Yes. This is a cone shape that we can form if this triangle of R rotate about the y-axis through 360 degrees. Now to get this volume, to get the volume of the solid, we need to use the formula, start from pi, and now we need to integrate from 0 to 9 because now the function is into the piece of region is actually rotated about the y-axis. We need to integrate with respect to y. And the lower limit and upper limit also we need to get it from the y-axis, that is from 0 to 9 for this case. And the function should be x squared. So how do you get the x squared? Now the function given which is bounds the region is y equals to 3x. So now we need to get the x in terms of y. X will be equals to y over 3. So we need the x squared. We need to find the square of the x. So meaning that we need to square both sides. We have a y squared over 9 over here. So now you need to put the y squared over 9 into the x squared here. You have pi 0, 9, and x squared. You need to substitute by the y squared over 9. Then integrate with respect to y. So now we just back to the normal integration. For the 1 over 9, we can just factor it out. If you feel that it's disturbing or what, you can take it out. Or you may leave it inside, no problem. So integrate as usual. You have a pi over 9. Integrate y squared. You have a y squared, a y cubed over 3. And put in 0, 9. So now we are going to substitute the upper limit inside. This is a pi over 9. Substitute the upper limit minus substitution of the lower limit. Substitute 9 inside, you have a 9 cubed over 3. And substitute the 0 inside, you have 0. So finally, you should have 27 pi unit cube.